Hello friends, welcome to Multiverse. And friends, you must be aware that when a large star basically dies after a supernova, what remains after the supernova is either a neutron star, or if the star is large enough, it will leave a black hole behind. Well, so this is exactly what we want to discuss today. We don't want to discuss black hole, but we want to discuss neutron stars. What are the different types of neutron stars? And there is one particular type of neutron star known as magnetars, and why they are so scary. Magnetars and what are these things? In today's program, we will discuss about specifically magnetars. But I think I must clarify that these are the types of a neutron star, but much powerful, very powerful, and also having a huge amount of magnetism into them. They generate a lot of magnetism. In fact, we will discuss how much magnetism they have. But first of all, let us understand what is a neutron star. Neutron star is a body which is left behind after a supernova explosion or a hypernova explosion, and all the material is converted into neutrons. That means, you know that the atoms have a nucleus which has mostly neutrons and protons, and the electrons rotate around the atom, around the nucleus. So, because of the extreme pressure and temperature, the electrons are, they collapse into the nucleus itself. And once they collapse into the nucleus, the electron will combine with proton to make a neutron. So what happens is that all the material in the star which is available is made of neutrons. So there is no atom. It is like there is no charge in it, and there is no segregation of positive and negative charge. Everything is made of neutron, and that is why this is a very compact body, not more than 20 kilometers in diameter, very small. But in 20 kilometers, it contains the mass of an entire star. So this is the very complex structure, and I'm sure a lot of us already know about neutron stars. But what is so peculiar in the magnetars, which is different, which differentiates it from the usual neutron star? The other thing is that magnetars are basically very scary objects. They are so powerful. Their magnetism is so powerful that even if you approach close by, at the distance of 1,000 kilometers from the star itself, it will rip apart your body. It will the magnetism will rip apart the atoms itself into its components. And suppose we replace the magnetar near the moon, we place a magnetar near the moon orbit, instantaneously it will erase all electronic data. So that is the kind of magnetism the magnetar has. And so far, while the Milky Way has more than 200 billion stars, estimated stars, we have identified only 23 magnetars in our Milky Way. So they are very scary objects, most extreme objects, but they are not found in great numbers. So that is another peculiar thing about magnetars. And depending on the size of this supernova, the size of the explosion, the more compact neutron star is formed. And neutron star is also spinning very rapidly. And because of this, motion of rotation, it is basically an intermediate state, and it stops the neutron star from collapsing further into a black hole. So the angular momentum basically balances the gravitational force, and it stops body to further collapse into a black hole, and that is how we get the neutron star. So you can imagine this is a very extreme structure, very extreme body, and we can find neutron stars. In fact, we can find neutron star in pairs also, but magnetars are only 24 that we have seen so far. In terms of the magnetic force of the magnetar, it is so powerful that it is, if you compare with the Earth's magnetic field, well, you know that Earth's magnetic field is the field which protects the entire life on the Earth from the deadly radiation which is coming from space and also from the sun. So the magnetic field is around Earth is pretty strong. It deflects everything else which is coming towards the Earth. Well, the magnetar magnetic field is a trillion times that of the Earth. So you can imagine that how impressive this magnetic field would be, how huge this magnetic field would be, and how it must be shaping the space-time also around the magnetar. So that is why this is a very, very unique and very different kind of a object, and scary also at the same time. In terms of understanding the neutron star further, as I said, the neutron stars are spinning very rapidly, and when it is spinning, it may be absorbing certain gases or certain material around the neutron star. And when this material falls onto the surface of the neutron star, it falls with a speed of almost the speed, a fraction of the speed of light. And at that speed, when it collides with the surface of the neutron star, even a small atom will explode like a nuclear bomb. And because of that, all the activities which is going on around the neutron star is very, very energetic. And since it is rotating, it accumulates this energy into two laser type beams emanating from both poles, which is north and south pole of the neutron star. And when we look at it from the Earth, we see that as a pulsating object several times a second. So that is why we also call a neutron star a pulsars, because whenever there is some activity going on neutron star, we see them as the jets of energy emanating from the poles of the neutron star, like a laser light or a laser beam. And we since they are very far off, we see them as a pulsations, and we can actually measure, and these are very accurate pulse. So we can actually give these pulses as a characteristic to the neutron star, and that's how we identify different neutron stars and differentiate between multiple neutron stars. But these pulsars are not necessarily magnetars. Every neutron star may be a pulsar, but every pulsar may not be a magnetar. However, a magnetar also is a pulsar. So when you look at the magnetar, it is demonstrating a huge amount of magnetism around it, and the magnetism is so strong that it actually affects the space-time around the neutron star. Well, many things are affecting the space-time around the neutron star. That is the gravity of the neutron star also. But the magnetism also plays a major role, and because of this very strong magnetism, we don't know really what impact it has on the atoms of the material which is falling into it. And we also see that these are also pulsars. That means the material is definitely falling into it and exploding into a huge energetic explosions, and this explosion is then guided towards the poles, and from there it emanates from both sides as pulsating beams. So magnetars also gives out pulsating beams, at the same time demonstrate huge magnetism around the around this structure. When it comes to identify the magnetars, we have special equipment to identify, measure their magnetism, and as you can see, these magnetars are mostly found outside or the outer periphery of the galaxy. The magnetars are never been seen inside the galaxy or nearby. They are always been in the outer periphery of the galaxy. That means they are almost outside the galactical plane. And that is another mystery, that why magnetars are found only outside the galaxy and not within the galaxy. And that is something mystery that needs to be solved. However, we also don't know why certain neutron stars become magnetars and why certain neutron star remains a pulsar. That is also a mystery, and I think this requires more study, more observations, and more research in order to determine what are the parameters which makes a normal neutron star into exhibiting huge amount of magnetism and hence called magnetars. So friends, I hope you enjoyed today's information. If you know something more than what I've told you, please send in your comments. And as always, thanks for watching, and I will catch you in the next edition of Multiverse.